So today we're going to start talking about the extrema. And so the extrema is your mathy word. So this word right here. This is your mathy word for the maxes. Oh, I hope I can spell maxes right. Maxes and mins. We have two different kinds of maxes and mins. We have local and we have absolute. So I'll tell you the difference of both of them here in a second. All right, so a maximum, and this is like the math definition of it. I'll give a more simple definition, but is when the graph is increasing to the left of x equals c and decreasing to the right of x equals c. Then at x equals c, the value of f is largest, and that is called a maximum. So what that means is if you go from increasing, oh, that's a highlighter. If you go from increasing to decreasing, you get this little hump, and at the very, very top of the hump would be your maximum. All right, so minimums are pretty much the opposite. So the mathy definition, when the graph is decreasing to the left of x equals c and increasing to the right of x equals c, then at x equals c, the value of f is the smallest. So minimums are going to start with decreasing and then go increasing. And so this value right here where you change, that would be called your minimum.
So the lowest and highest points of the graph.
Mm-hmm. Yep. So all at the little humps there, it's like the top and the bottom of your hills and the bottom of your valleys, all of those kind of things. Now, something that you do need to watch out for is yesterday, and most of this class so far, we've dealt with x values, right? Domain is x values, intervals are x values, all of those things are x values. Well, when you're talking about mins and maximums, the y value is going to give you your max or your min. And if you think about it, it kind of makes sense. Because if we're talking about the highest point of my graph, I'm talking about the biggest y value. And if you're talking about the lowest, you're talking about the lowest y value. So that is why we use the y values to determine what the max and the min are, because the y-axis is telling me how high and how low I'm going. So extrema, range, those are the two things that uses y values. Almost everything else uses uses x values. I want to say everything because I can't think of anything else that uses y values, but I'm just not 100% sure. Alrighty. So now let's talk about what an absolute extrema is. All right, so an absolute max or an absolute min. It's kind of what it sounds like. The absolute maximum is the very, very highest point on the entire graph. The absolute minimum is the very, very lowest point on the entire graph. All right. So if we're saying that your point here is greater than all the other range values. All right, so it's bigger than everything else. It's called an absolute an absolute max. And if your point here is less than all the range values, it's an absolute min. All right. We have some other names for them, and I don't know why they have two different names, just to make things confusing. Relative and local, same thing. Absolute, global, same thing. So depending on what math book you're reading or what math teacher you have, they might interchange those. All right, so some books will say global and some books will say absolute, but they're the exact same thing. So just kind of keep that in mind, like if you go to a college class or something and they start using the word global and you're like, what the heck is global? It's the same thing as absolute. And then same thing with local and relative. All right, now, we kind of already talked about it, but relative extrema or local extrema are going to be where you change from increasing to decreasing or decreasing to increasing. It's going to be the humps and valleys. All right, so think humps and valleys. Humps and valleys, that's where you're going to get your relative, or your local extrema. Because that's where you're going to switch from increasing, decreasing, decreasing to increasing. Absolute is very, very highest, very, very lowest. Highest, lowest. Now the one tricky thing to remember here is that absolute extrema can be endpoints. Because an endpoint can be your very, very highest and your very, very lowest. But an endpoint is not relative. It is not a relative extrema. All right, so that's kind of always a tricky concept to get. So relative are all the humps and the valleys. All right, those are all relative. Your absolute is the very highest and the very lowest. Your absolute can be an endpoint because that endpoint could be your very, very highest. But endpoints are not relative because it doesn't change from, it doesn't give you that hump. All right, so let's look here at this graph. All right, it says identify the absolute extrema and the relative extrema of the graph given. So on this first question, it says, what is the absolute maximum? So if I'm looking at my graph, what is the very, very highest point? G, but what is wrong with G?
It's not a hump.
It's the highest, but it's an open circle.
Yeah.
So it's not included, so it can't technically be your absolute max. So we're gonna put none here. If it was closed in, your absolute max would be G. But because it's open, your graph is getting really, really close to G, but it's not ever gonna use G. And so we can't really say what our absolute max is. All right. But that is the very, very highest point of the graph. All right, what about the absolute min?
B.
B, yep. Very, very lowest. B is your absolute minimum. All right, what about a relative max?
D.
D, it's the top of the hump right there.
A.
So
We have
A,
multiple, but A is not a hump.
it's not a hump, so it's not relative.
Okay.
So it's a possible.
Oh, because it can't be an end, or it just can't be open. That's right.
Right. And that's just the it's a tricky thing about it because it could be absolutes but not relative. Okay, so what about my relative min or mins? F and B.
So even though it's absolute,
It's also relative because it's a hump. Yep.
It's just all the points that are at the bottom.
if it's a hump.
If it's a hump, it's going to be a relative. Yep. So whether it humps this way or humps this way, that'll be a relative. And then for your absolute, just very highest, very lowest. Alrighty. So down here. All right, so it says identify the following, and it's kind of written it's written more out instead of just writing the coordinate point. It's saying the relative maximum is blank where x equals blank. So
1 and 2. So 1 and 2.
wait, which one? Yeah, 1 and 2. Yep. So this coordinate point right here, 2, 1, I'm recognizing that to be my maximum. So remember, the y value is telling you the maximum because that's the how high it's going. So your maximum is 1, but it's at x equals 2. All right, so what about for a minimum?
0, 4.
Yep. So minimum at 0, where x equals 4.
-8.
Yep. And the other one is -8 when x equals -3. So those are all relative. They're all the humps. Which one of these would be the absolute minimum?
Does it have to be a point?
The
Or maybe like infinity?
-8 or the -3.
It does have to be a point. If it's infinity, it doesn't exist. So yeah, the minimum is -3, -8. Does it have an absolute maximum?
No.
No, because it's going up to infinity. Yeah.
So would you say none or infinity?
Either one. Yeah. I probably won't ask you for an absolute if there's not one. That would be a weird question to ask. So I'd be okay with either one. Okay. On this next part here, we're going to get this giant monstrosity out because we're going to look at calculator stuff. And they didn't put the 84 on my iPad yet, so bear with me here. I know there's Desmos, but I want y'all to be able to see it like on,
an actual.
like on what you're going to have to do on your calculator. You know what I'm saying?
Yes.
Because Desmos is nice. Desmos, it will just automatically pop up, but on y'all's calculator, you're gonna have to do the second trace thing.
Right.
All right. So on a couple of your questions on your homework, it's gonna say like use a graphing utility to figure out. It's gonna ask you about increasing and decreasing intervals, and it's gonna ask you about max and min, and then we'll talk about the boundedness here in a second. All right. But you are gonna have to graph them. All right, so you're gonna have to graph them in the calculator. We talked about how to plug in an absolute value yesterday. So what I want to do today is I want to show you how to find max and mins. All right, so I'm gonna type this guy into y equals x cubed minus 4x plus 1. All right, so just remember that the f of x there, that means y, and it doesn't matter whether it's f or g or h or anything, like that guy's y. So you would go to y equals and you would type your function in. All right, so you get a graph that kind of looks like this, which matches what I have on my paper. All right, so what I need to do is I need to find the max and the min points, because I need those values for my increasing, decreasing intervals. I would need those values to state extrema. Like, those values are important. Do y'all remember finding max and mins last year?
Yeah,
A little bit, yeah. All right, so what you're gonna do is you're gonna hit second trace. And then depending on what you want to find, you're going to hit min or max. See, this is driving me crazy because you see it keep auto-focusing. Is that not driving you nuts? I'll have to do it for long now. All right. So depending on what you're trying to find, it's going to depend on what you're clicking. So this one up here, this is a maximum. So I'm going to go down here to maximum. And you need to move your little spider over there on the left side of the point you're trying to find. All right, so this is the maximum. This is what I'm trying to find. So I'm going to move my spider anywhere over here on the left side. It says left bound right there. So move it on the left side, and then you're going to hit enter. You get this little dotted line that pops up. That line should be on the left side. Then you're going to take your little guy. You're going to move it over here on the right side, because it says right bound, so you're going to move it on the right side and hit enter. So the arrows move it on the right side. Don't move it too far right, like just go a little bit right. And then where it says guess, just hit enter again. And so some kind of ways that you can check yourself, it should say what you're finding down here at the bottom. So like if it says minimum and you're trying to find a maximum, you know you hit the wrong button. Also, your little spider should pop up to that point you're finding. So if your spider is like popping up down here, that is also not right. So it should pop up there on the maximum. So my maximum point, oh, did I just clear it out? Nuts. All right, so this point right here is negative 1.154, comma, 4.079. Oh, you can't see that. Let me zoom back out. All right, so to answer the question, we would say that my maximum value occurs at 4.079, or it's The maximum value is 4.079, and it occurs at negative 1.154.
Do you care how many decimal places we can keep?
3. Because if you take calculus next year, that's what you need for the AP test. I don't care if you round, or you can try, like, I don't know if you noticed, I'm kind of in the habit of not rounding. So on, well, I guess that one doesn't round. Does this one round? Yeah, on this one. So I'm okay with you putting 1.154, or you could put 1.155 because the 7 rounds the 4 up. But get used to doing 3 decimals, because if you're a junior, I'm hoping you'll take calculus next year, and that's what you have to do. What's up?
On the curve, do you want us to put x equals, or can we just put the number?
You can just put the number.
Okay.
Mhm. But if you put x equals, that's fine too. Okay. Has anybody worked ahead and gotten the minimum? Yeah.
Can you fix my calculator?
Yeah.
It's in different language.
Oh. I knew there was one here. I always forget where the language button is. It's in Spence Silva. English. Alright.
So negative 2.079, positive 1.155.
Okay, 1 point what?
So the local value occurs, or it occurs at 1.155,
Yeah.
and then it is at negative 2.0.
Negative 2.079. Perfect. Oh, you can't see that either. All right, so if you are struggling with the calculator, that might be where you want to start on your homework while I'm here to answer questions. But if you did the minimum, you should have gotten this point here, 1.154, negative 2.079. And so when we are writing over here, the minimum value is negative 2.079, and it occurs at 1.154. All right. Now, the only thing I need to say here about using the calculator, because you're going to have to on your homework, is when you are doing increasing and decreasing. Remember, for increasing and decreasing, you are just using the x values. All right, so don't worry about the y values for increasing and decreasing. So we would say this guy is increasing from negative infinity to negative 1.154, decreasing from negative 1 to 1.154, and then increasing again from 1.154 to infinity. So you don't even use the y values at all for increasing, decreasing. All right, so for those kind of intervals, you don't do that. All right, I'm just gonna finish out here on this lovely thing here. This is my last thing I'm gonna talk about, and that's boundedness. And so boundedness all just kind of relates with the range and the max and the mins and all of that good stuff. So you have 4 different options. You can have a graph that is totally bounded, which just means there is some kind of absolute max and absolute min. It's bounded above and below. You can have a graph that is bounded below but not above, which means you have a absolute minimum but not an absolute maximum because it is going up forever. And vice versa, you could have an absolute maximum but no absolute mins because it's going down forever. So that would be bounded above but not below. Did I say that backwards? Whatever, you get the idea though, right? Okay, and then you have something that also could be not bounded at all because it is going up forever and down forever. So it doesn't matter what happens in the middle. All right, so I see that asymptote, whoa, hello. I see the asymptote, like I know, but all that matters is the ends. Is it going up, is it going down, are we bounded at all? So if it's asking about boundedness, like I think it's the last part on your homework, you have to graph it and it wants you to tell me if it's bounded or not. That's all, you just have to put bounded above or bounded below. You don't have to do anything else. You're just graphing it in the calculator, looking at the graph, and determining what kind of bound it has. Okay? So, rest of class, you have to work on your homework. You have a homework quiz tomorrow. So, if you have any questions, let me know.